Hello everyone. Today we're going to continue our class about engineering economy, lecture 15. Um, Actually, we are already at the very end of the chapter 4. And if I ask you to recall what we have learned in chapter number 4, then I think if you have watched the video, I hope that you understand that we have learned many different types of cash flows already. Okay, first we learn how to draw the cash flow diagram, and then we learn different types of cash flows, like cash flow occurred at the present time, so we call it P, right? And then we also learn cash flows occurred like at the end of every compounding period, and we call it annuity. We also learned that cash flow can happen at a later time in the future, so we can call it future value. So these are the three different types of cash flows that occur on the timeline. Okay, so this is something I hope that you already understand. And today we're going to learn the mixture of all these types of cash flows. Okay, and today's class we're going to see many examples, because mixed cash flows are what happen in the real life. Okay, you won't have like just single type of cash flow for every case. Usually what you have is mixed types of cash flow occur on the timeline. So today's class is very important, and also a little bit complicated. So I want you to pay attention on these examples. Before we jump into the examples, we have attendance check number 2 available, and it's due on October 26th at the midnight. So it's the same rule, same requirements as the attendance check number 1. So you can just go and click the attendance check and answer those multiple choice problems as many times as you can. Those questions are just based on very basic concepts we have learned in the class. You can also find it on a textbook. Okay, so if you read the book, if you watch the video, you won't have any problem getting 100 point about the attendance check questions. Okay, so here is the subject for today. We're going to learn evidence calculation involving multiple interest formulas. By multiple interest formulas, actually we are talking about multiple types of cash flows. So we said we have learned different types of cash flows: present value, annuity, future value, right? And if you remember in the previous classes, we only talk about how do we convert a single type of cash flow to another single type of cash flow. So we talk about, for example, in this one, What we have on the timeline is just the annuity, right? That's our single type, one type of cash flow. And the question usually is, how do you find the future value from that annuity? How do you convert the annuity to a future value at the end of the timeline? So what you want to do is to find f given a, okay? And you can see that you always deal with a single type of cash flow, okay? And another example on the right side, sometimes you are given the present value and then you're looking for the annuity equivalent to that present value, right? So again, you're find A given P, and in this case, you are still dealing with single type cash flows. Okay? But in the reality, it's not always the case that you always have single type of cash flow to convert to compound to another time or to another type of cash flow. Usually what you have is, for example, on this chart, on this diagram, during the 8 years, you have different types, multiple types of cash flows going on. First, you might have cash flow going out by the end of the period 1, and then you have another volume of cash flow going out at the end of period 2, and then you need to spend another amount of dollars by the end of the third period, right? There are three cash flows, okay? And compared to the time at 0, these three cash flows are all can be called some future cash flows because they are happening at a later time compared to the time 0. We always call the value at time 0 present 0, okay, which means it's a present value at 0 time, or we label it as P0. And so all the cash flows happening later than that time point will be some future cash flow compared to this time 0, okay? So on this cash flow, you have a future cash flow at time 1, you have another future cash flow at time 2, and you have another cash flow at time 3. So there are multiple cash flows. Although they are the same type, they are all future value, but there are multiple ones with different amount. And beginning from the end of the 4th period, you can see on this chart on this diagram, we have annuity, which is $400, okay? So this is the second type of cash flow, which is annuity. So in this diagram, we have future value and we also have annuity, okay? They are on the same diagram. So for this problem, we need to find a way to convert different types of cash flow to some single type of cash flow. We can convert the F to some present value at 0 time. We can also convert the annuity to some present time value. And the present value from the future values, which is F1, F2, F3, we can say that's the first part of that present value. And the part of the present value will be converted from the annuity, and that's gonna be the second part. Okay, so in the end, if we want to know what is the total present value out of converted from the future values and the annuity values, then actually we need to know that it is from two parts. One part is from the future value, F1, F2, F3. The other part is from the annuity values, the 400, beginning from the end of the 4th year and until the end of the 8th year, continue until the end of the 8th year. Okay, so this is what this is what I want to talk about. It's the multiple cash flows, multiple types of cash flows going on the same cash flow diagram. Okay, so that is more complicated, but it is more real case. Okay, so we need to find a way to calculate this type of problem. All right, so to explain the approach you're gonna use to calculate this multi-cash flows, multi-types of cash flow problems, here is an example, and it is very very useful case because you always find such problems in your future work. So if you are a business owner, you want to have your construction company, you want to buy equipment at the beginning, right? Maybe excavator. You either want to buy it, or you want to lease it, or you want to just rent it time to time. You have different options. So here, just imagine you are going to buy an equipment, maybe an excavator, for your factory, for your construction company, and you want to use it for 8 years. Okay, so that's the year, the lifetime you want that equipment to serve. You can either buy a second-hand equipment, right? If you want to have something cheaper but still workable, you can find a used one, just like a used car, right? Another option is you buy a new one. Well, they cost different, but the maintenance is also different. Okay, just imagine if you buy a second-hand one, which means your initial payment could be cheaper, but during the lifetime of that equipment, it might need more maintenance because it's already used by someone else. So it's easier to get broken, and you might need to spend more every year to maintain, to check, and to repair. Okay, and compare to a new one, I mean. And at the end of that 8 year, you might want to resell it to or trade in. And then that equipment has been used by a previous owner and you, so it's gonna be very old. So the price you can resell it is gonna be very low. Make sense? Okay, another option is you buy a new one, a new excavator, maybe. So the new machine is brand new, which means the quality is very good. So every year, the money you spend on maintenance, on checking it, repairing it, might be very low compared to an old one, compared to a used one, right? And also, in the end of the 8 year, if you want to resell it or trading, the price for this new equipment could be higher than the second-hand one because it's just used by one owner for 8 years. So it's still very new, okay, in a good condition. But to buy this new machine, initially you need to pay much more than the second-hand one. So you see the difference, right? And that's very typical. No matter if you want to buy a new machine or you want to buy a car or you want to buy a house, right? These this is the similar situation you need to face. So I would say this example is very good. So let's just see if we have two options like this. How do we decide which option is better than the other one? Based on the cost. Okay. All right. So think about that. If we only consider cost, so for option 1, we have initial payment as cost, we have yearly maintenance as cost, we have the but in the end we're gonna sell it at a lower price because it's used one. So all these cash flows, we can convert them to the present value, P0. And then you can imagine it could be negative value. If it's negative, it means it's your cost, right? So that cost is something, actually equivalent to the price of the equipment, the maintenance fee of the equipment, and the salvage fee at the end. Now keep that value in your mind. So you already have a value from option 1, right? That's your true cost. And for option 2, you also need to spend, one cost is the price, second is the maintenance, yearly maintenance, third, you're gonna receive some money at the end if you trade in. But those cash flows, you also need to convert them back to the present time so that you can compare these two options. Okay, so and you can imagine that maybe for the second option, you also have a negative value because that's the money you spend going out. But the two values are gonna be different. So in the end, you want to have a P0 for the alternative 1. You also need to have a P0 for the alternative 2. Okay? And you want to compare this to p-values. Okay, we write P0 option 1 and the P0 option 2. So just let you know, you're gonna have two p-values from these two options. And then you want to compare which one is less negative because they're all cost. They're all money going out. So whichever is less negative versus P0 option 2, which one is less negative? That's gonna be your better choice because you're gonna cost less if you go with that option. Make sense? And this negative, it doesn't mean it's the value lower than 0. Okay, not lower than 0, but meaning it's a cost. Okay, so now you can understand the logic. Okay, so we want to convert for each option, we want to convert every cash flow back to a present time, and then we compare the value of the present cash flow for both options and find the better solution. Okay, so now let's take a look at these two options. Option 1, you buy a used one at 18,000. Okay, and then every year the machine needs this much, 34,400 to operate and maintain. Okay, you want to use it, you want to maintain it. That's the total net cost every year for using that machine. At the end of the year, you can trade in or sell at 2,000. Okay, So the 18,000 is the cost, so it's money going out, and this 34,400 is also a cost, so it's negative, and the 2,000 is something positive. Okay, that's just the symbol we use for accounting. Negative means it's a payment, positive means it's a receiving. Okay, and that's the option 1. Option 2, you can buy a new one at a much higher price, which is 60,000. That's your cost, so it's still negative. And every year, the maintenance fee and operation fee is gonna be 25,000. So you see that is lower than the 34,400 because it's newer, and still it's a cost, so it's negative. And at the end of the year 4, the machine needs a major maintenance, which will cost 9,400. Okay, so at the end of year 4, you're gonna have a major maintenance for this equipment, and that major maintenance is also the cost, so it's negative. And at the end of the A year, you can trade in or sell at a higher price compared to the 2,000 for the option 1, right? And that's the money you receive in the end because you sell it, so it's positive. Okay, so these are the 2 options. Clear? And then now what we want to do is, first we deal with the first option. We draw the diagram, we convert the different types of cash flows back to the present time. Okay, and then we sum all the present time values together to get a total present value for option 1. So the first thing, you draw a diagram. Okay, so we can draw a diagram here. It's 8 year. So starting from 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay. At the beginning, you want to pay for the price. So that's a cash flow happening at the time 0. And it is going out cash flow, so it's an arrow going downward. It's 18,000. And after that, at the end of every year, the machine needs 34,400 to operate and maintain. So 34,400 is, that arrow should be longer than the amount of 18,000. And it's still going downward because that's the cost. So at the end of the first year until the end of the 8th year, as long as you want to use it for the previous 1 year span, you need to pay the maintenance and operation fee. And that annuity is 34,400. At the end of the 8th year, you can trade in or sell at 2,000. So that's your receiving. So it's an arrow going upward. And it's very short compared to the other cash flows. And it is 2,000. Okay? So now take a look at this cash flow. You have 3 types of cash flows. You have the first type, which is P value, right? And then you have a second type cash flow, which is annuity. And you also have a third type of cash flow, which is a future value, right? Compared to the 0 time, this 2000 is happening in the future time, right? So that's a future value. So you have 3 types of cash flows. 3 types of cash flows. Okay, and then you want to convert all the 3 cash flows back to a present time. Okay, so now what you want to look at is, wait a minute, so we need to write the interest rate, which is 8%. Okay, that should be given in the problem statement. Let me see if it's given. Yeah, it's 8%. Okay, so now what we're looking at is the present value at 0 time for all the 3 cash flows. So what is the P0? And we said it is converted from 3 different types of cash flows, right? So it is composed of 3 parts. Okay, so you can write P01. It means the present value from the first type of cash flow, okay, part 1. And that cash flow is the initial payment of the 18,000, right? And it is a type of p-value. And also we said it is a negative value because it's a cost. And this negative doesn't mean it's a value lower than 0. It only means it's a cost, money going out, okay, compared to the receiving. And you have another part, you can label it as P02, which is from the annuity. Of how much? Of 34,400. Okay, and we said the type is annuity. Okay, and then of course it's a cost, so it's negative. We have a third part of the present value, which is from a future value. That is the salvage price at 2000. And we said what type is it? It is a future value. And it is a receiving, so it's a positive. Okay? So now you have 3 parts. And then you want to convert each part back to a present value. So what is the P01? What is the present value of a present value at 0 time? You don't have to convert anything because the 18,000 is already happening at the time 0. So there's no converting, no compounding needed. So you can just write negative 18,000. Okay, and P02 is from the annuity. Okay, first it's negative. It's from the annuity, which means you are looking for a p-value given annuity, right? At the interest rate of 8%, and the compounding period is 8 years. So the equation you're going to use is A times a factor, which is to find P given A, given I, given N. okay? And negative, the A is 34,400. The factor is P given A. I is 8%. N is what? Is 8. Because you have this annuity for 8 years, right? And then we need to look at the table to find out what is the factor. So let's see, in the table, the column you're looking at is to find the P given A. So that's the column. And the row is number of years, it's 8. So the value you have for the factor is this one, 574.66. So that's 5 point. $5.7466. Okay, and the final results is, don't forget about the negative sign. It is 1976.83.04. Okay, so that is the present part of the present value coming from the annuities. And now you need to calculate the P03, which is a positive value converted from a future 2000. So you're looking for a present value given a future value, right? So the equation is F times a factor P slash F I% N to find out P given F, right? So positive, the F is 2000. The factor is P given F, 8% and 8 because it's at the end of the 8th year, okay? So positive 2000 and check the table. So now you are looking for P given F, and let's use another color. Okay, that's the column, and the number of years is still 8. So now the factor you're looking at is this. Okay, so just go back and then put it here, 0.5403. Positive, do the calculation, it is 1080.6. So now you have already converted all the 3 types of cash flows back to the present time. And then you can sum them up to find out the P0. So P0 is P0 part 1 plus P0 part 2 plus P0 part 3. Okay, and P0 part 1 is negative 18,000. P0 part 2 is negative 1976.83.04. P0 part 1 is something positive. It's 1086.6. Okay. And where do you have them? This one is this. Okay. this one goes here, and this one goes here. Now it's clear, okay? The total value is gonna be negative 214,602 or 214,602.44. So that is the actual cost for all those cash flows, okay? And that cost is something you want to compare with the other option. So now let's do the same thing to the option 2. Okay, first we draw the diagram. We draw it here. So still 8 years, 0, 1, 2, 3, 4, 5, 6, 7, 8. So at the beginning, you want to pay for a new machine, new equipment, which is more expensive. It's more expensive than the used one, 60,000. And after that, every year you need to spend a little bit lower, 25,000 as your for your maintenance and operation. Okay, so it's an arrow going downward but shorter. Until the end of the 8th year. And that annuity is 25,000. But at the end of the 4th year, you're gonna have a major maintenance at 9,400. So that's something additional to this 25,000. Okay, so that's let me draw it. Okay, let me put the annuity here. So you're gonna have additional arrow going downward, shorter one, which is 9,400. Okay, and at the end of the 8th year, you're gonna have trading receiving. Okay, receiving for trading. Excuse me, and the price is 8,000. So it's a very short arrow going upward, which is 8,000. Okay, so that's the cash flow. So on this cash flow diagram, we have how many types of cash flows? Or how many different cash flows? Let's see. You have the first part, which is a P value. We have this 9,400 compared to the time 0, it is a future value, right? So it's a F. And we have another annuity, and then we have another future value at the end of the 8th year. Okay, so we have four types of cash flows, or 4 cash flows. If you want to say the future cash flow of 9,400 and 8,000, they're the same type of cash flow, then that's fine. You can also say they're different amount, so they're different cash flows. So now we have 4 parts to convert: the present value, the first future value, the annuity, and the second future value. Okay, so right now, if you want to find out what is the present value for those cash flows, there are 4 parts. So P01, the first part is from the initial payment of the 60,000. Okay, and we said it is type P value and it is cost, so it's negative. And the second part of the total present value is gonna be from the 9,400, that's a future value. Future payment for major maintenance, which is 9,400, and it is compared to the time 0, it is a future value, and it is cost, so it's negative. The third part is from the annuities, right? 25,000 for every year. So annuity of 25,000, and it is annuity. The type of cash flow is annuity. It is also negative because it's cost. And at the end of the 8th year, you have the fourth part to convert to the back to the present time. It is your salvage price at 8,000. Compared to the present value, it is a future value, so it's F, type is F, and then it is a receiving, so it's positive. So that's the 4 parts you want to convert back to the present time. So P01, still, that is already happening at the present time, the time 0, so you don't have to do any compounding or converting. So it is negative, of course, it's a cost, 60,000. So no calculation needed. P02, the part 2, it is from the 9,400 future value, right? So negative. The equation is for looking for present value given future value. So it's gonna be F times a factor to find P given F, I percent, N. And the future value for at the end of the 4th year is 9,400. And the factor is P/F. I is 8%. But the number of periods is what? It's not 8, it's 4. Why? Because it's happening at the end of the 4th year. So between the year 0 and the end of the 4th year, there are only 4 periods, 4 years. Okay? So it sounds like you're going to jump 4 times back to the present. Okay? So 4 periods, which means n equals to 4 for 9,400. Okay? So here it is, n is 4. And I want to just show this to you. Okay? Alright, so now you're looking at the table and then find out the factor. So the table is, you're looking for present value given the future value. Of course, this table is the table of I equals to 8%, okay? So that's the table you're looking at. And then find out the column find the p given f, and because number of year now is 4, so the row is 4th, and here is the value, the factor you're looking at. So the factor is 0.7350. And the end results for this part is 6909. Then let's calculate the P0 from the annuity. Okay, so still it's negative. You're looking for present value given annuity, so the equation is A times a factor, find the P given A, I%, N. It's negative. A is 25,000. The P is P slash F, slash A. %. This annuity occurred at the end of every period for 8 times, so the N now is 8. So go check the form, the table. Now you're looking at the column of P slash A, right? To find the P given A. So that's the column. And N is 8. So here is the factor. It is 5.7466. So the final result is 143,665. Okay, the last part, P04. It is a future receiving, so it's positive. And you're looking for p-value given a future value. So the equation is gonna be f times p slash f I% n. So it's a positive. F is 8,000. P slash f 8%. Now, how many years between the 8th year and the present time? It's 8, okay? So now you have to jump how many times? 1, 2, 3, 4, 5, 6, 7, 8, okay? So now your number of periods, the n, is gonna be 8. Okay? This from here. Okay? So I want you to pause here and then to think about the part P02 and the P04, why their n is different. Okay? This is very important. And okay, so now let's continue. It's positive, it's a receiving. So 8,000 times a factor. Okay, now let's look at the factor. It's to find the present value given future value. Okay, so this column, but the number of years is 8. So this is gonna be your factor. Okay, and that factor is 5403. 5403. So the final results for the part 4 is gonna be 4322.4. Okay, so now your P0 is gonna be the sum of the 4 parts. So P01 plus P02 plus P03 plus P04. Okay, so it is negative 60,000 plus, or you can just write the negative sign directly. Okay, negative 6909 negative 143,645 plus 4322.4. So the final is negative 206,251.6. Okay, now let's take a look at these two options. Okay, so P0 for option 1 is what? Is this, okay, let's copy it here. Negative 214,602.44. P0 for option 2 is negative. Negative means it's a cost, okay? 206,251.6. So if you want to choose which one is the better one, think about that. You need to pay either 214,602.44 or you need to pay 206,251.6. You want to choose the less negative, right? You want to choose this one because you're going to pay less, which means the option 2 is a better option. Okay, so this is a very typical question when it comes to the real cash flow in real life, and you have multiple cash flows for each option, and you want to compare which one is the better solution. Okay, and this problem is only about the cost, so you want to choose the less negative one because you're gonna pay less. All right, now let's take a look at the example from the textbook. This is even more complicated because you are not only converting everything to the present time, it also asks you to convert everything to a future time. And it also asks you to convert everything to a new annuity, equivalent annuity. So you're gonna do, 3 different types conversions. The first is you have this cash flow, multiple cash flows on the diagram. You want to convert everything back to the present. Okay, so everything back to the present. This is annuity back to the present. Okay, that's how you find the P0. And another question is to ask you convert everything back to a future time. So annuity back to a future time. This 500 back to a future time. This 200 back to a future time. This 100, no, not back to, compounding to a future time. So it's F8. And then it asks you to do a third thing, to spread these cash flows to every year, okay, to find out the equivalent annuity. So you want to distribute this 100 to every year. Okay, every year but not the first year. Because by definition, the annuity equation can only be used when the first payment is at the end of the first year. So this is not true. Okay. And you want to distribute the 200 to every year. Okay. And the same thing, you want to distribute the 500 to every year. And you want to distribute the annuities of 400 to every year. Okay, so you see this is gonna be more complicated questions to answer. Okay, but don't worry, we have our factor method. We can do it. So now how do we do it? First, let's take a look at this cash flow. Okay, so this is not a specific problem. It's not related to any business or company or type of factory. It's just a generic cash flow diagram. So on this diagram, you have a series of year-end cash flows extending over 8 years. Okay, so you have 8 years. The amounts are 100 for the first year, 200 for the second year, 500 for the third year, 400 for each year from the 4th through the 8th. Be careful, it's not from the 1st to the 8th, okay? So be careful about that. This could represent something like the expected maintenance expenditures for a certain piece of equipment or payments into a fund. So it's just a generic situation. Note that the payments are shown at the end of each year, which is a standard assumption for this book and for economic analysis in general. So in economic analysis, we always assume that the cash flow happens at the end of every period. Okay, so the first question, question A, what is the present equivalent expenditure of all these cash flows? So find the P0. Question B, the future equivalent expenditure. So F8. 8 means it is the future value at the end of 8th year. And the question C, the annual equivalent expenditure. Okay, so of these cash flows, the annual interest rate is 20%. Okay, so now you're looking for the equivalent present value, the equivalent future value, and the equivalent annuity of these multiple cash flows. So first, let's see how do we convert all of them back to the present time. Okay, so the P0 is what? So we have, first you need to check how many types of cash flows you have. So we have this 100 at the end of the first year. We have 200 at the end of the second year. We have 500 at the end of the third year. Although there are some future values, kind of future values, but they're different amount. So you have to convert them differently, okay? So we label them as different types of cash flows. And then you have all these annuities. Okay, so this is annuity. This is some future value. You can label it as F3 because it's happening at the end of year 3. Just to make clear for yourself. And this is F2. And this is F1. Okay? So now you have how many parts? 4 parts. So same thing. You want to just write it down. So P01. The first part is from the 100. Okay? And then that is a type of future cash flow. Okay? In this diagram, because everything is going downward, so we're not going to label them negative or positive. But of course, you can do that. So everything is negative, but actually we don't have any positive ones, so we don't need to label everything. Okay? So here I don't label it as negative. But again, there are still costs. You just need to keep in mind there's no positive values to add up, so we don't have to differentiate them. So second part is from 200, and also it is a type of future cash flow. The third part is from the 500. Okay, again it's a future value. And the fourth part is from the annuity of 400, and it is annuity type of cash flow, right? Okay, so you can also label it here. The P01 is to find the P given F, okay? P02 is also to find the P given F. P03 is, the problem is also to find the P given F. P04 is to find the P given A. So this is just easier for you to find out the equation and to find out the factor. Okay? You can do this to the previous question as well. So now let's calculate what is P01, 02, 03, then 04. So the first part is from the 100. So the equation you're going to use is F times P given F, I% and N. And I is 20%. Okay? So now the F is 100, P/F, I is 20%. What is the N? How many periods between 0 and the time 1? Or how many times you need to jump from time 1 back to time 0? 1, right? So N is 1, okay? So here N is 1. So 100 times, what is the factor? Okay, this is the table for I equals to 20%. You're looking for P given F. So that's the column. And here, let me use this color. The n is 1. So this is your factor. Okay, so it's 0.8333. So this is 83.33. Okay? And now let's calculate the part 2 of present value. It's from 200. Still, you're using the same equation because you're looking for P given F. Same equation, but with different values. Now it's 200. 20% the same. What is the n? Between the time 2 to time 0, how many times you need to jump back? 1 and 2. So n is 2, okay? So now the n is 2. So it's 200 times, what is the factor of n is 2? Same column because you're looking for P given F, but it's gonna be the second row. So this is your factor. So it is 0.6944. So it's 138.88. Okay, what is the third part? Same equation because you're still looking for F given P. Same equation, but different values. So 500 P slash F, 20%. Now what is the n? To answer this question, consider between 0 and the time 3, how many periods you're jumping. So it's 1, 3, 2. Okay? So now n is 3. So here is 3. Excuse me. So it's 500 times, what's the factor value for n is 3. So still you're looking at this column because you're looking for P given F, but n is 3. So this is your new factor. So it is 0.5787. It is 289.35. Okay, last part is P04, which is from the annuities. But be careful, this annuity begins from the end of the 4th year. So if you use the annuity equation, you only convert these annuities back to a year before when it's begin. Make sense? So by equation, the definition or the requirement of the equation, you only convert the annuity back to this time. Okay? So first you want to use the annuity equation. You are looking for some value at equivalent value at the time of 3, at the end of year 3, which is from the annuities. Okay, and that value you can call it P3 because that's some present value compared to the later annuities. So I would say it's P3. Okay, And then once you have that P3, you can convert that P3 to P0. Okay? And the way you convert that P3 to P0 is to use that P3 as a future value and convert that future value to P0. So the first thing is you find out P3 or you convert annuity to equivalent value at the end of year 3, and that value could be called P3 because compared to the year 4 it's a previous time, so it's a P3, okay? And then you use P3 equals to F3 because compared to the year 0, P3 actually is gonna be a value at a later time, so you can also label it as F3 compared to 0, right? And then you convert F3 to P0. So that is the 3 steps you want to calculate P0 for. This part is complicated, so pause here and re-watch this part. Why cannot we just use the annuity equation? Because if you use that equation, you are just converting the annuity back to one period in advance. Because you are starting at the year 4. So by using that equation, you only convert all the annuities back to year 3. Okay? And then you need to deal with how do you convert some value at year 3 back to year 0. That's why we have these 3 steps. Okay? So now let's do it. So first thing is you convert annuity to some present value at year 3. So that equation is to find P given A, right? So it's A times the factor P slash A I% N. And this is, we said this is P3. Also, it can be written as F3 compared to the year 0. Okay, and if you have something at a future time at year 3, how do you convert that to the present value 0? You use this value, which means you use the whole term of this time another factor, which is to find the P given some future value, right? I% and N. Okay, so this is the entire calculation. And A is 400 factor P slash A. I is 20%. What is the N? Because we said by the definition of this equation, the N is gonna be how many times you jump back to the previous year, right? So for all the annuities, how many times between this one period before to the end? So it's 1 time 2, 3, 4, 5. So for this annuity problem, the n is 5. Okay, so here is 5. And another factor will help you to jump from some future value at year 3 to year 0. So what is the time? What is the n? So we already have it here. N is 3 because you're converting some value at year 3 to year 0. So n is 3. Okay? So here you want to be careful about why do we have n is 5 in the first factor for the annuity problem, and why do we have 3 here for converting a value from year 3 to year 0. Okay? This is all about the definition and how do you use the annuity equation. Okay? The annuity equation only convert the annuities back to 1 year before one is begin. So you already have 4-year annuities, and 1 year before plus the another 4 years is gonna be 5 years, 5 periods. So this is 5. Okay? So now let's go check these factors. Let's write it down here. First factor, P/A. So same table, P/A is this column. Number of periods is 5, so that's this value. So it's 2.9900 times another one. It's P/F. And the number of year is 3. So it is this one. So 0, 57, 87. So the final is 692.26. Now you have the 4 parts of P0. Just sum them up. So P0 is P01 first part plus second part plus third part plus fourth part. And the final results is 1203.82. Okay? So the tricky part for this question, for this problem is this process. Okay? And how do you find out this n, and how do you find out this n? Okay? So if you don't understand this, rewatch the video. And also this is an example from textbook on the page of page 133. So just go check it. Okay? Make sure you understand this equation, this calculation. Okay. Then it has another question. Question B, the future equivalent expenditure F8. So now the problem is much easier. You don't have to do the multiple times conversion again. Okay? You only need to, because you already have P0. So you only need to convert that to P0. Compounding that P0 to some future time to find out what is the F8. Right? P0 is something you already calculated in the first question. So now it's very easy. So F8 is, the equation is to find out F given P. So it's gonna be P times a factor F slash P I% N. And the P is gonna be the P0 times F slash P 20%, because you need to compound how many times? 8 times, 8 years. So the N is 8. So P0 is what? P0 is 1203.82 times the factor is F slash P. So F slash P, that's the column, and the number of years, 8. So that's the factor. So it is 429.98. 429.98. So it's 50,176.19. So if you convert everything to the future time, the equivalent value is gonna be 5,000 something. Okay? And if you distribute everything to annuities, that's gonna be the third question. So annuities is gonna be, you don't have to do the conversion of every cash flow because you already have your present value, right? You calculate it out at the first question. So you only need to distribute this present value to annuities. Okay, so to find out annuity given P, the equation is P times a factor A slash P I% N. P is P0, A slash P 20%. How many years you're gonna distribute the money? It's 8 years, so it's 8. So P0 is something you calculated out in the first question. It is 12,003.82, and the factor of A slash P, that's the column, number of years 8. So this is your factor, 2606. So the final result is 313.73. Okay, so this is how you convert all different cash flows back to the present, compounding to the future, and then distribute them to every year. Okay, and usually we will just do the conversion just to use multiple cash flow conversion once, and then we have one single equivalent value for all the cash flows, like this one, like we have the P0, and then we just convert the P0 to a future value or to the annuity, so that you don't have to do the conversion for every question. Okay, so this is all for today. I try to explain everything slowly and then write down the annotation clearly. So I want you to just make sure you understand what I'm saying here. If you have questions, please don't hesitate to either leave the question in the discussion board or just email me so that I can, make small videos for somebody who has problem. Okay? But again, this multiple cash flow problem is really important. So make sure you understand. All right. So I'll see you next time. Bye bye.